In the previous lecture, we looked at the pipeline module, and we noted that although we're using a lot of transformers from the feature engine library, we also have some custom ones that we've created in the features module of our package. Let's have a look at this module now. If we open up features py, we have two transformer classes. The first is the temporal variable transformer, and the second is the mapper. Now, these should be familiar from the Jupyter notebooks. You'll recall that we inherit from the scikit-learn base estimator and transformer mixin, and by doing that and also ensuring that we specify a fit and a transform method, we're able to use this to transform variables, and it's compatible with our scikit-learn pipeline. And again, here how this is getting used is similar to the notebooks, with differences including the config. So in our pipeline, when we're making use of, let's say, the temporal variable transformer, the difference is that we pass in the variables via the config. So temporal vars, year remod add, and then a reference var. Again, here in the config YAML, we can see that's year sold. And just to refresh our memories, we can see that then when we apply the transform method, we're going to do the year sold minus the year the remod was added. So this will be, instead of like 1941 or some other normal year, we get an integer, which is the result of making that subtraction. And in our mapper class, we also apply a transformation where we take these features. So let's have a look at the pipeline, and where we use our mapper, we specify which variables we want to transform and map. So we have qual vars, for example. Look in our config, these columns, then, and we have the mappings for them. So we're going to perform these transformations on these values. Now, a few things to note from the features module. We could easily create additional features here by defining another class which adhered to this structure, so inheriting from the base estimator and the transformer mixin, defining a fit and transform method, and in the transform method we would specify what transform we wanted to apply, and then we could add it to our pipeline at whatever point in the pipeline made sense depending on the transform that we're looking to apply. So this is how we're structuring things in our package. So we can bring this to life a little bit more, I'm going to show you a sample test for this little bit of feature engineering we're doing. So if we go to the tests, you see here we have the test features file, and here we have a test for our temporal variable transformer. So a few bits of setup that we do here. We have a fixture, which is the sample input data. You'll find this in our conf test file. And if you're not familiar with the conf test file, please review the PyTest primer lecture that we have available in this section. And what we do in our sample input data is we make use of our load dataset function, which is from our data manager. We looked at that earlier in the section, to load in our test data file. So this will load in our test CSV file, and that then becomes available to use in our test. And what we do is we have this given when then structure, so a bit of setup first. We instantiate our temporal variable transformer, passing in the expected temporal variable, so that's going to be year remod added. And we just check that right now with our sample input data, the first row of the year remod added is 1961. Then we trigger our transformer fit transform method on the sample data, and after the transform is applied, we check, okay, now in that first row the value switches from 1961 to instead 49. Let's run our tests and make sure they're working as we expect. If we look in the tox.ini file, you'll see that we have a test package environment that we can run. So let's use that one, tox-e test package, and you need to make sure that you're in the section 5 directory where our tox.ini file is to run this command. If you haven't run it before, it will need to install the test dependencies, but I've already run this, so it's available and runs pretty fast. and both of these tests are passing. We have test make predict, which we'll be looking at a bit later, and we have the test temporal variable transformer that we're looking at right now. So this is working. Let's break it and see if we understand why. This is actually a good exercise for you to try now. If you pause the video and try and break the test without doing something like causing a syntax error, but instead try and break it in the spirit of the testing. So let's pause the video now, and when you return, I'll show you how you can go about this. Okay, welcome back. So we know that we expect after performing a transformation that 1961 will have been changed. So if we were to change the value to 1961 and then rerun the tests, we're getting a failure because we're seeing 49 but saying we're expecting 1961. So this is telling us that our transformer is working as we expect. And in this case, we've just checked the first row. It's better practice to check the entire data frame, or at least a larger subset of the data frame, but this gives you an idea of how you can go about constructing these sorts of tests. Feature engineering is a very common cause of bugs, so really important to ensure that any feature engineering code is tested. And in our example repo here, we have a couple of example tests, but in reality you'd want much greater test coverage and to be more thorough in your own applications. Obviously depending on what your risk tolerance is and what the implications are for you if you have a mistake in your model. Another takeaway from this lecture is that we now have a structure for adding new bits of feature engineering, new transforms we can apply in our pipeline. So don't focus so much on the specifics of any one particular transformer. Instead, understand how you can then adapt this structure to your own models and your own data science problems, and reuse this as a template which you can modify to suit your own needs. Okay, in the next lecture we'll start bringing things together and making predictions.